Let's just go over in general the transformations of an exponential function. We've done transformations before where we talked about how the transformation is indicated outside of the function, inside of the function, and how we can recognize those reflections and shifts and compressions and stretches. So in this case, we'll start with the most basic. F of x equals 2 to the x. So 2 is our base, x is our exponent, and the c that we might have is just 1. 1 times 2 to the x. So outside the function, what might that look like? Well, what if we had f of x equals 2 to the x plus 1? This is happening, you raise to the power. Here's our function, the power of x. This happens outside. Outside the function affects the y values. It's, let me also write vertical. It's a vertical transformation. So this would indicate that every point on the original function here would shift up 1 unit. If we had f of x equals 3 times 2 to the x, so now our c from our function standard form is 3. This is outside the function. You raise 2 to the x first, then multiply by 3. So the function takes place, and then something's happening outside of that. And this is a vertical stretch by a factor of 3. So here we would take every y value and add 1. It's affecting the y. Here we would take every y value and multiply by 3. And by y, I mean the y coordinate of our points. And here's one other way we could have a transformation outside of the function. This does not mean raise negative 2 to the x power. This means raise 2 to the x power, then add this negative. That's done last. Exponents come before. This is considered multiplying by negative 1, and that is multiplication. Remember your order of operations. Exponents come first, so you would raise to the power, then put the negative on. So this means reflect over the x-axis, which of course changes your y value, not your x value. If you reflect over the x-axis, x is still the same. So here we would multiply our y values by negative 1. Add 1, multiply by 3, or, and I'll just make a note, multiply y by negative 1. This one would multiply y by 3. This one would add 1 to y. For any points that were originally on here, if we saw these transformations, all outside the function, they affect the y, and they are vertical changes. Now, what about inside the function? What does that look like, and what happens when we see those? Okay. All right. Inside the function. These affect our x values. They're horizontal changes. Okay, so f of x equals 2 to the x minus 1, let's say. Okay, see, that has to happen before you raise to the power. So it's in the function. It's not after you raise 2 to the x. You have to make this subtraction happen, then raise to the power. That's inside the function, and this is means shift right. Remember, with x, we always have to think of the opposite sign. Shift right 1 unit. In other words, take your x's, x coordinates of your points, and add 1 to them. If that was x plus 1, we would go left. All right, f of x equals. Inside the function would be, what did we have? We had the stretch, so this time we would have, but what we're going to see is something like this, 2 to the negative x. Okay, so again, the negative is inside the function, not out here in front, but inside. You have to raise to that negative power before you raise to the 2, and this will be a reflect over the y-axis. Now, reflecting over y doesn't change your y values of your points. it changes your x values. You would multiply x by -1. And if we had f of x equals 2 to the 3 times x, that's when you're going to see that horizontal compression. This would be a compression by a factor of 3. Now, I'm not sure I've seen that a lot in this chapter, but I'm going to go ahead and show you that. This is the one of all of these that it does not seem to occur that much. Okay, so now if you can recognize these and then learn the points on the basic exponential function, you can easily transform. So let's look at those real quickly. What does that basic function look like? And so we were looking at f of x equals 2 to the x. There are 3 points on this and every graph of a function. So let's just look at how we find those. X and f of x. When x is -1, we say f of -1 equals 2 to the -1 equals 1/2. 1 over 2 to the +1. When x is 0, f of 0 equals 2 to the 0, which of course is 1. And when x is 1, 2 to the first power, which of course is 2. And what we find is that on all of these basic functions, no matter what the base is, if we have f of x equals a to the x, these 3 points are on every graph. They are -1, 1 over a. See, when it was 2, it was 1 over 2. If that had been 7, it'd be 1 over 7. That point, the point 0, 1 is going to be on every graph, because if you raise any power to 0, you're going to get 1. And when you put in 1, you're going to have whatever your base is to the first power. These 3 points are on every graph of this basic function. So to use transformations, we'll look at what is our base. These would be on the basic function. Now, what is the transformation implied? So I'll work some of those in the next video.